Hello everyone, I am going to present a group project for fundamentals of programming. Our project is Smart Hospital Word Monitoring System. The system is designed to manage patient data and monitor word safety using Python. Here you can see my team members who works on this project. Now we can move next slide. We had 5 main goals. The first one, we use double OP to organize patient data using classes. So second one is use NumPy and Pandas to create and handle health records. The third one is we performed statistical analysis to check if word environment is stable and safe for patient. Fourth one is we simulated a real world scenario to see how infection is spread in word using grid differentiation method. Finally, we use matplotlib to visualize all our results with clear graphs. Now we can move to the next slide. Now let's look at how our system works. Our blog workflow has 4 main steps. Step 1, we design double OP framework to track patients. Step 2, we generate synthetic data. For example, we simulate health vitals for 50 patients using NumPy. Step 3, we process this data using Pandas and save everything into CSV file for easy record keeping. Step 4, we model infection pathway to see how virus moves through the world. As you can see in the diagram, it is complete process with data generation to final visualization. That concludes my part of the presentation. Thank you for your attention.
Today I am going to explain part A and part B of our project. Part A, object-oriented design. In this part we use object-oriented programming concept. First, we create a class called person. It includes common details like name and age. Then we create the patient class from the person class. It includes patient details like temperature, heart rate, and infection status. We also create critical patient and regular patient classes. These classes show patient details in different ways. This method made our programming simple and organized. Let's move to next slide. Part B, synthetic data generation. In this part, we create data for 50 patients using NumPy random function. First, we use np.random.gradient to create random age and heart rates. Second, we use np.random.inform to generate body temperature between 33 and 40 degrees Celsius. Last one, we also use np.random.choice to randomly select word and infection status. Finally, the data was stored in the Pandas data frame for analysis. Thank you.
Hello everyone. I will be taking through the statistical analysis and data management phases of our project. Here on slide 5, we focus on temperature statistics. To evaluate the overall condition of the hospital wards, we calculate several core health metrics. Looking at the code snippet, you can see relied heavily on pandas. We use the describe function to efficiently extract the mean of the average thermal state as well as the minimum and the maximum temperatures to instantly spot critical cases. We also utilize the median function to find central value that safety ignores extreme fever outliers. Now let's move to the next slide. To how organize all this information. On slide 6, we have data management. Here, we converted our raw data direction into structural pandas data frame. As listed in the data operations, we first verified our data's integrity using the df.head function. Then, as shown in the code block, we filtered the data frame to count the exact number of infected patients. This is crucial step for real-world isolation planning. Finally, we use the CSV function to export our completed dataset into hospitaldata.csv file permanent record keeping. Thank you.
Hello everyone, I am DW for this work. Today I will show you how simulated infection discovers smart hospital ward. To keep ward safe, we need to understand how infection can move around. In part E, we look at how an infected patient moves down hospital hallway. We use simple system called random walk. The patient starts at the center with position 0. The patient takes exactly 100 steps. With every step, patient randomly moves either left or right. We use Python to draw this path. The graph shows time on the bottom and patient's position on the side. This helps hospital staff see how patient can move around unpredictably over time. Now let's look at part F, where we see how a virus is spread across the entire room. Instead of just hallway, we made grid that look like a 20 by 20 room layout. Here is how the virus spreads in this room. The infections start right in the middle of the room. Over time, the virus randomly moves into the spaces next to it. Every time a new spot gets the virus, it changes color on our map. We made a blue map. We made a blue heat map to show this. At a single glance, doctors and management can see exactly how a virus moves outward from the single point. These simulations make it much easier for hospitals to plan ahead and stop outbreak before they go. Thank you.
Thank you, Dalu. Now I will be presenting our system's execution results and conclusion. When we run our Python code, the system generates three main outputs. First, the statistical output. The system instantly processed data for 50 patients. It calculated an average temperature of 36.09 Celsius and flagged exactly 25 infected cases. This gives hospital staff an immediate look at overall ward health. Second, the random walk graph. This graph tracks an infected patient's random movement down a hospital corridor over 100 steps. It shows how a patient moves relative to their starting point. Third, the diffusion heat map. This metric simulates how a virus spreads outward from a single point. Our patient 0 at the absolute center, across the 20 by 20 watt layout. It helps visually predict how a virus might expand. To conclude, our project shows exactly how simple programming tools can solve real-world healthcare problems. By using NumPy and Pandas, we can easily generate and keep track of live patient data. Our infection models give doctors a clear visual way to predict and lock down virus outbreaks before they spread through a ward. Ultimately, this project proves that we can use smart programming to build proactive solutions for modern hospital management. Thank you.